At 6:47 a.m. on June 12, 1942, Wehrmacht mechanic Hans Müller crawled under a broken-down Panzer IV near Karkov, Ukraine, watching transmission fluid leak into the dusty ground beneath him. 24 years old, 2 years maintaining German armour, zero solutions for the crisis-destroying Army Group South. The Eastern Front had consumed 3,200 German tanks in 18 months, not from enemy fire. From mechanical failure, transmissions seized in the Russian mud, engines overheated in the summer heat, drive sprockets cracked under the strain of continuous operation. German industry could build replacement tanks faster than Soviet factories could produce T-34s, but they couldn't build them fast enough to replace the ones breaking down from exhaustion. The problem wasn't German engineering. Panzer IVs were magnificent machines when properly maintained. The Maybach HL 120 engine produced 300 horsepower. The transmission had 6 forward gears and 1 reverse. The final drive could push 25 tons of steel at 40 kilometers per hour across any terrain. But magnificent machines required magnificent maintenance, and the Wehrmacht didn't have time for proper maintenance. Tank crews drove their panzers 16 hours a day, slept for 4 hours, drove another 16. The advance towards Stalingrad couldn't wait for scheduled engine overhauls. Müller had seen the maintenance logs. Each Panzer IV was supposed to receive major service every 1,000 kilometers. Oil changes, filter replacements, track tension adjustments, transmission inspections. In peacetime, that maintenance happened like clockwork. In war, it happened when tanks broke down completely and couldn't move another meter. The result was predictable and catastrophic. Tanks that should have lasted 50,000 kilometers were dying at 8,000. Some lasted only 3,000 kilometers before their engines seized permanently. But Müller had discovered something the Wehrmacht High Command didn't know. Something that would keep German armour moving when it should have been scrap metal. Something that violated every regulation in the German Army Technical Manual. 3 weeks earlier, his panzer company had captured a Soviet supply depot near Belgorod. Among the supplies were 47 Ford trucks, Model 6 V8 engines, built in Dearborn, Michigan, shipped through Murmansk as part of American Lend-Lease aid. The trucks were supposed to haul Soviet ammunition and supplies. Instead, they sat abandoned when the Red Army retreated. Müller's company commander ordered the trucks destroyed standard procedure. Don't leave useful equipment for the enemy to recapture. But Müller asked for permission to examine them first. As a mechanic, he was curious about American engineering. How did Ford build trucks tough enough to survive the Russian front? The commander gave him 2 hours before the demolition charges went off. What Müller found changed everything he thought he knew about engines. The Ford V8 wasn't sophisticated. It wasn't precision engineered like German equipment. It was brutally simple. Cast iron engine block, basic carburetor, mechanical fuel pump, no complex electronics, no precision tolerances. The entire engine could be rebuilt with hand tools and basic parts, but that simplicity was its strength. The Ford V8 ran on anything that would burn. Regular gasoline, aviation fuel, diesel mixed with gasoline, even alcohol in emergencies. German Maybach engines required high-octane fuel refined to exact specifications. When that fuel wasn't available, the engines knocked, overheated, and died. The Ford transmission was even simpler. 3-speed manual with synchronizers that actually worked. German transmissions had 6 speeds and complex gear ratios optimized for specific operating conditions. When those transmissions broke, you needed specialized tools, precision parts, and factory-trained mechanics to fix them. When a Ford transmission broke, any mechanic with basic skills could repair it in a field workshop. Müller spent his 2 hours taking detailed measurements, sketching components, understanding how American engineers approached the same problems German engineers solved with complexity. The Americans chose reliability over performance, simplicity over sophistication, maintenance in the field over precision in the factory. When the demolition charges detonated and those Ford trucks disappeared in clouds of smoke and flame, Müller had already made copies of everything he needed. But copying American designs wasn't enough. Müller needed to test whether American solutions could work with German equipment. That night, he began the most dangerous experiment of his military career. Using parts salvaged from damaged panzers and techniques learned from studying those Ford trucks, he started modifying German tank engines to run more like American truck engines, simple modifications. Nothing that required factory approval or specialized equipment. Changes that could be made in field workshops by mechanics who understood basic principles. The first modification was the fuel system. German tank engines used complex injection systems that required precise fuel pressure and clean fuel lines. Müller replaced the injection system with a simple carburetor design copied from the Ford V8. The modification took 8 hours and used parts from 3 different damaged tanks. The result was an engine that could run on crude fuel, dirty fuel, even fuel mixed with oil or water. Performance dropped by 15%, but reliability increased dramatically. The second modification was the transmission. German Panzer transmissions had complex planetary gear sets that provided smooth shifting and optimal gear ratios. They also broke frequently under combat stress. Müller simplified the transmission by removing 2 gear sets and strengthening the remaining components. The modified transmission had only 4 forward speeds instead of 6, but those 4 speeds were nearly indestructible. A crew could abuse that transmission for months without maintenance, and it would keep functioning. The third modification was the cooling system. German tank engines used sophisticated radiators and cooling fans designed for optimal heat transfer. They worked perfectly when clean and properly maintained. In combat conditions, where dust and debris clogged the radiators constantly, they overheated and failed. Müller replaced the complex cooling system with a simpler design based on truck cooling principles: larger radiator surfaces, stronger fans, easier cleaning procedures. The modified cooling system kept engines running even when maintenance was impossible. These modifications violated every Wehrmacht technical regulation. Unauthorized changes to military equipment were grounds for court-martial. If Müller's experiments failed and caused tank losses, he would face execution, but if they worked, they might save Army Group South from mechanical collapse. Müller tested his modifications on 3 damaged Panzer IVs that were scheduled for return to Germany for major overhaul tanks that couldn't be repaired in the field. Tanks that were mechanically dead. The first test was June 8, 1942. Panzer IV 02, engine seized at 3,200 kilometers, transmission locked in first gear. Müller's crew removed the engine, rebuilt it with simplified components, reinstalled it with the modified fuel and cooling systems. Total time, 18 hours. The rebuilt engines started on the first attempt, ran smooth at all throttle settings. The simplified transmission shifted cleanly through all 4 gears. After 6 hours of testing, Panzer IV 02 was mechanically sound and ready for combat operations. The second test was June 10th. Panzer IV 05, transmission destroyed by shrapnel, cooling system damaged beyond field repair. Müller's modifications took 22 hours because the damage was more extensive, but the result was the same. A tank that should have been scrapped was running better than some brand new Panzers fresh from the factory. The simplified systems were so reliable that the crew reported no mechanical problems during 72 hours of continuous operation. The third test was June 12th, the morning this story began. Panzer 408, complete mechanical failure after 2,800 kilometers of operation. Engine overheated, transmission seized, cooling system blocked with debris, the worst-case scenario for field maintenance. Müller and his crew worked through the night, applying every modification they had developed. Engine rebuild with simplified fuel injection, transmission rebuild with strengthened components, cooling system replacement with truck-style radiators. 26 hours of work that should have been impossible in a field workshop. But it worked. At 6:47 a.m., when Müller crawled under that Panzer to check for leaks, he found none. The rebuilt engine was running perfectly. The modified transmission shifted smoothly. The new cooling system maintained optimal temperatures. Even in the Ukrainian heat, Panzer IV-08 was mechanically superior to its original factory condition. More reliable, easier to maintain, and capable of operating under conditions that would destroy a standard Panzer IV. What Müller didn't know was that his company commander had been watching. Captain Friedrich Weber had observed the impossible resurrection of 3 dead tanks, had seen his unit's operational strength increase from 12 tanks to 15 without receiving any replacements from Germany, had watched his mechanics perform miracles with hand tools and salvaged parts. Weber understood the implications immediately. If these modifications could be applied across the entire Panzer force, German armour would become mechanically invincible, but Weber also understood the risks. These modifications were unauthorized. They violated technical specifications established by German engineers who had spent years perfecting Panzer design. If higher command discovered what Müller was doing, the consequences would be severe. Not just for Müller, but for Weber and every officer who had permitted unauthorized modifications to military equipment. The Wehrmacht was built on discipline and adherence to regulations. Innovation from the ranks was not encouraged. Weber faced an impossible choice: report Müller's activities and lose the most effective mechanic in his company, or keep quiet and risk court-martial if the modifications were discovered by higher command. The decision was complicated by combat reality. Weber's company was scheduled to advance towards Stalingrad in 10 days. They would need every operational tank for the assault. Tanks modified by Müller were more likely to survive the advance than tanks maintained according to official procedures. On June 13th, Weber made his decision. He would not report Müller's modifications to higher command, but he would not officially authorize them either. The modifications would continue unofficially. No written records, no formal documentation. If questioned, Weber would claim ignorance. The responsibility would rest entirely with Müller. It was a coward's choice, but it was the choice that kept German armour moving towards Stalingrad. What Weber and Müller didn't realize was that their secret was about to spread far beyond their company. Other mechanics in the regiment had noticed the improved reliability of Weber's tanks, had observed panzers that should have broken down continuing to operate flawlessly, had started asking questions about maintenance procedures and parts availability. The word was spreading through the maintenance crews that someone had found a way to make German tanks as reliable as American trucks. Reliable as American trucks. By June 15th, the rumours had reached Sergeant Klaus Hoffmann's maintenance section, 30 kilometres south of Weber's position. Hoffmann commanded 12 mechanics responsible for keeping 23 Panzer IVs operational across 2 companies. His tanks were dying at the standard Wehrmacht rate: 1 engine seizure every 4 days, 2 transmission failures per week, cooling system breakdowns. Whenever the temperature exceeded 30 degrees Celsius, Hoffmann's unit was bleeding mechanical casualties faster than they could be replaced. When Hoffmann heard whispers about a company maintaining perfect operational readiness without receiving factory parts, he didn't believe it. No Panzer unit on the Eastern Front maintained perfect readiness. The mathematics were impossible. But when his informant mentioned specific tank numbers that had been written off as total losses now appearing on daily operational reports, Hoffmann paid attention. Dead tanks didn't resurrect themselves without explanation. Hoffmann sent his most trusted mechanic, Corporal Ernst Becker, to observe Weber's company during routine maintenance operations. Becker was 28 years old, 8 years of automotive experience before the war, skilled enough to understand complex mechanical systems at a glance. His instructions were simple. Discover what Weber's mechanics were doing differently. Learn their techniques, Report back with actionable intelligence. Becker arrived at Weber's position on June 17th under the pretense of delivering spare parts. He spent 6 hours observing Müller's crew service, their panzers. What he saw contradicted everything he understood about German tank maintenance. These mechanics weren't following standard procedures. They were using simplified systems, modified components, unauthorized parts. Their engines ran on fuel that would destroy a factory specification Maybach. Their transmissions shifted smoothly, despite having fewer gear ratios than regulation equipment required. Most shocking was the maintenance philosophy. German doctrine emphasized precision, complexity, and adherence to engineering specifications. Müller's approach emphasized simplicity, reliability, and field expedience. Where German engineers designed elegant solutions optimized for peak performance, Müller had substituted crude solutions optimized for continuous operation. The results spoke for themselves. Weber's tanks ran when other tanks failed. Becker returned to Hoffmann with detailed observations and rough sketches of the modifications he had witnessed. Hoffmann studied the information for 2 days, comparing Müller's techniques against standard Wehrmacht maintenance procedures. The modifications violated regulations, but they solved real problems that were destroying German armour faster than Soviet anti-tank guns. On June 20th, Hoffmann made the same choice Weber had made a week earlier. He authorized his mechanics to begin implementing Müller's modifications on their most damaged tanks that were already beyond regulation repair procedures. If the modifications failed, those tanks would be lost anyway. If they succeeded, Hoffmann's unit would gain operational strength without waiting for factory replacements. The first modified tank in Hoffmann's section was Panzer IV, engine destroyed by overheating, transmission locked in second gear. Corporal Becker led the modification work, applying techniques learned from observing Müller's crew. The rebuild took 31 hours because Becker was learning the procedures while implementing them. But the result matched what he had witnessed at Weber's position. A dead tank restored to full operational status, using field expedient modifications. Word spread faster now. Mechanics talked to mechanics across company boundaries, regiment boundaries, division boundaries. The Eastern Front communication network that kept German forces informed about Soviet movements also carried information about mechanical innovations. By the end of June, maintenance crews across Army Group South knew that someone had discovered how to make German tanks mechanically invincible. But the spread of information created new problems. The modifications required specific knowledge, specialized techniques, and careful attention to detail. Mechanics who attempted the modifications without proper understanding created disasters. Engines exploded, transmissions seized permanently. Cooling systems failed catastrophically. For every success story, there were 3 failures. The failure rate convinced many commanders that the modifications were dangerous experimental procedures that threatened operational readiness. Colonel Heinrich Müller commanded the 15th Panzer Regiment, 48 tanks spread across 3 battalions. His unit had suffered mechanical losses equivalent to an entire battalion in the past month. When reports reached him about unauthorized modifications that promised to eliminate mechanical failures, he faced the same choice that had confronted Weber and Hoffmann: ignore potentially valuable innovations or risk his career by permitting unauthorized changes to military equipment. Müller chose a third option. He would investigate the modifications personally. On July 2nd, he visited Weber's company to observe their maintenance operations and interview their mechanics. What he found was a unit operating at 100% mechanical readiness, despite conditions that should have reduced them to 50% strength. Their tanks ran smoothly, shifted cleanly, and maintained optimal operating temperatures under combat stress. Müller interviewed Müller directly, demanding technical explanations for each modification. Müller demonstrated the simplified fuel system, explained the strengthened transmission components, showed how the modified cooling system resisted debris contamination. Every answer revealed deep understanding of mechanical principles and practical experience with field maintenance challenges. This wasn't random experimentation. This was systematic engineering adapted to combat conditions. More importantly, Müller observed the psychological impact on tank crews. Crews operating modified panzers displayed confidence that crews with standard equipment lacked. They knew their tanks would start every morning, knew their transmissions wouldn't fail during critical maneuvers, knew their engines wouldn't overheat during extended operations. That confidence translated directly into combat effectiveness. Crews who trusted their equipment fought more aggressively than crews who feared mechanical failure. On July 5th, Colonel Müller made a decision that would change how the Wehrmacht maintained its armour. He authorised the implementation of Müller's modifications across his entire regiment. Not officially. Official authorisation would require approval from higher command, technical evaluation by engineering staff, and formal modification to Wehrmacht maintenance procedures. That process would take months. The advance towards Stalingrad couldn't wait for bureaucratic approval. Instead, Müller issued verbal orders to his battalion commanders. Their most experienced mechanics would receive training in the new modification procedures. The training would be conducted by Müller and his crew, who would rotate through each battalion to demonstrate proper techniques. The modifications would be implemented gradually, starting with the most damaged tanks and expanding to include all operational equipment. The training program began July 8th. Müller and 2 assistants travelled between battalions, spending 3 days with each maintenance section. They demonstrated modification procedures on actual tanks, supervised initial attempts, corrected errors before they caused damage. The program was intensive, practical, and effective. Within 2 weeks, every mechanic in the 15th Panzer Regiment could perform basic modifications. Within a month, they could execute the complete rebuilding process. Results were immediate and dramatic. Mechanical failure rates dropped 73% across the regiment. Operational readiness increased from 68% to 94%. Fuel consumption decreased because simplified engines ran more efficiently than complex factory systems. Most significantly, tank crews reported increased confidence in their equipment. They knew their panzers would function reliably under combat stress, but success created new challenges. Other regiments demanded access to the modification procedures. Division headquarters received reports about dramatically improved mechanical readiness without explanation. Army Group South intelligence officers began investigating unusual maintenance activities that suggested possible security breaches. The secret that had started with 1 mechanic and 3 dead tanks was becoming too large to contain. General Friedrich Paulus commanded the 6th Army, spearhead of the drive towards Stalingrad. His armour strength had declined steadily since the offensive began, not from combat losses, but from mechanical failures. By mid-July, nearly 40% of his tanks were non-operational due to maintenance problems. The situation threatened the entire campaign timeline. Tanks that couldn't move couldn't support the infantry assault on Soviet positions. When intelligence reports reached Paulus about unusual maintenance activities producing exceptional results, he ordered immediate investigation. His staff identified the source as modifications developed by Wehrmacht mechanics using techniques derived from captured American equipment. The modifications violated regulations, but produced measurable improvements in operational readiness. Paulus faced a command decision that would affect the entire Eastern Front campaign. Standard military procedure required reporting unauthorized modifications to higher command for evaluation and approval, but standard procedure would halt the modifications pending official review. That could take months while 6th Army's mechanical situation continued deteriorating. Alternatively, Paulus could authorize continued implementation while the official review process proceeded that risked his career if the modifications proved effective, but it might save his campaign if they proved successful. On July 18th, Paulus chose expediency over procedure. He issued orders authorizing the implementation of field-developed maintenance modifications across all armoured units in 6th Army. The modifications would be treated as emergency battlefield innovations pending formal technical evaluation. Unit commanders would be held responsible for results, but they would not be penalized for implementing improvements that enhanced operational capability. The authorization transformed scattered experiments into systematic implementation. Every maintenance section in 6th Army received training materials, technical specifications, and qualified instructors. The modifications spread from regiment to regiment, division to division, until thousands of German tanks were running on systems designed by a 24-year-old mechanic who had studied Ford trucks in a captured Soviet-supplied depot. The transformation of 6th Army's maintenance capabilities produced results that exceeded every projection. By August 1st, operational readiness across all armoured units averaged 91%, the highest level achieved since the Eastern Front campaign began. Tanks that should have been scrap metal were leading advances toward the Volga River. Panzer crews who had grown accustomed to mechanical breakdowns now trusted their equipment completely, but the success created an unexpected problem. German logistics had calculated fuel and ammunition requirements based on historical mechanical failure rates. When tanks stopped breaking down, they consumed resources at rates that strained the entire supply system. Fuel convoys that should have lasted 10 days were empty in 7 ammunition stockpiles designed for specific operational tempos were exhausted ahead of schedule. The Wehrmacht supply chain wasn't prepared for armour that actually worked reliably. Lieutenant Colonel Hans Dietrich commanded supply operations for the 24th Panzer Corps. His job was ensuring that fuel, ammunition, and spare parts reached frontline units before they ran out. The mathematics were complex but predictable. Historical data showed that 30% of German tanks would be non-operational at any given time due to mechanical problems. Non-operational tanks didn't consume fuel or fire ammunition. Dietrich's supply calculations included that 30% reduction in resource consumption. When operational readiness jumped to 91%, Dietrich's calculations became worthless. His fuel convoys were arriving at empty depots. His ammunition trains were finding units that had expended their basic load days ahead of schedule. The improved mechanical reliability that enhanced combat effectiveness was creating logistical chaos throughout Army Group South. On August 3rd, Dietrich received reports that multiple panzer battalions were approaching fuel exhaustion 3 days before scheduled resupply. The battalions had maintained continuous operations because their tanks weren't breaking down, but continuous operations meant continuous fuel consumption. Dietrich faced an impossible choice: divert fuel from other units to prevent operational halt, or accept that improved reliability created new vulnerabilities. He chose diversion, stripping fuel allocations from infantry divisions to keep the panzers moving. The decision violated supply protocols but maintained offensive momentum. However, it created a cascade effect throughout the logistics system. Infantry units delayed their advances waiting for fuel. Artillery batteries rationed their fire support to conserve ammunition. Support elements struggled to maintain schedules disrupted by resource reallocation. The irony wasn't lost on experienced officers. German engineering had created tanks so reliable they threatened to outrun their own supply system. The modifications that solved mechanical problems created logistical problems. Success in one area generated failure in another. The Wehrmacht's complex military machine required balance between all components. Improving one component without adjusting others created system-wide instability. Major Wilhelm Steiner served as operations officer for the 14th Panzer Division. His responsibility was coordinating between combat units, maintenance sections, and supply elements to maintain operational effectiveness. The modified tanks had simplified his maintenance coordination dramatically. Fewer breakdowns meant fewer repair requests, fewer parts requirements, fewer scheduling conflicts, but they had complicated everything else. Combat units equipped with reliable tanks advanced faster than planned, outrunning their assigned objectives and creating gaps in the offensive line. Artillery units struggled to keep pace with rapidly advancing armour, reducing fire support effectiveness. Infantry divisions found themselves protecting extended flanks because Panzer spearheads had pushed beyond their intended boundaries. The entire operational tempo had accelerated beyond what doctrine anticipated. Steiner's daily briefings became exercises in crisis management units, reporting ahead of schedule positions. Supply convoys requesting route changes to reach rapidly advancing formations. Artillery commanders demanding updated firing coordinates as target areas shifted faster than maps could be updated. The mechanical reliability that enhanced individual unit performance was degrading overall operational coordination. On August 7th, Steiner attended a division commanders conference where the implications became clear. Every division reported similar problems. Reliable tanks were advancing too quickly for coordinated operations. The offensive was becoming a series of independent thrusts rather than a coherent campaign. German doctrine emphasized combined arms coordination, but combined arms required synchronized movement. When one component moved faster than others, coordination collapsed. General Walter von Seydlitz-Kurzbach commanded the 51st Army Corps, responsible for coordinating 4 divisions in the drive towards Stalingrad. His corps included 2 panzer divisions equipped with modified tanks and 2 infantry divisions using standard equipment. The performance gap between modified and standard units was creating tactical problems that threatened the entire offensive. The panzer divisions advanced 60 kilometers in 3 days, capturing objectives scheduled for day 7 of the operation. The infantry divisions advanced 28 kilometers in the same period, maintaining the pace doctrine anticipated. The gap between armoured and infantry forces created a salient 40 kilometers deep with no infantry support. Soviet forces could attack the exposed flanks or isolate the advanced panzers by cutting their supply lines. Seydlitz-Kurzbach faced the fundamental challenge of commanding mixed capability forces. His modified panzer units could maintain operational tempo that his standard infantry units couldn't match. Doctrine required combined arms coordination, but coordination required similar movement capabilities across all elements. The mechanical improvements that enhanced panzer performance disrupted the balance that made combined arms effective. His solution violated every principle of armoured warfare doctrine. He ordered his panzer divisions to halt their advance and wait for infantry support. Tanks that could maintain continuous forward movement were told to stop and dig defensive positions. The decision protected operational coordination at the cost of exploiting mechanical advantages. It was tactically sound but strategically wasteful. The halt order reached panzer crews who had grown accustomed to reliable equipment and rapid advances. Tank commanders who had spent months dealing with mechanical failures couldn't understand why functioning equipment meant stopping. Crews who had gained confidence from reliable machinery lost morale from artificial restrictions. The psychological benefits of mechanical reliability were negated by operational constraints. Captain Franz Weber commanded a company of modified Panzer IVs in the 16th Panzer Division. His tanks had operated for 12 days without significant mechanical problems, advancing through Soviet defensive positions that should have required weeks to penetrate. His crews displayed confidence and aggression that came from trusting their equipment completely. When the halt order arrived, Weber's first reaction was disbelief. His panzers were mechanically capable of continuing the advance. His crews were psychologically prepared for extended operations. His fuel and ammunition status supported another 3 days of combat operations. The Soviet forces in his sector were withdrawing in disorder, offering opportunities for exploitation that doctrine emphasized seizing immediately. Every tactical principle Weber understood argued for continuing the advance. But the halt order was explicit and final. Weber's company would establish defensive positions and wait for infantry support. They would surrender tactical initiative to accommodate forces equipped with less reliable machinery. The mechanical superiority that should have provided operational advantages was being deliberately neutralized to maintain doctrinal coordination. Weber's crews received the order with confusion and frustration. They had spent months learning to work around mechanical failures, adapting tactics to accommodate unreliable equipment. Now they were learning to work around mechanical success, adapting tactics to accommodate reliable equipment that other units couldn't match. The irony was bitter for soldiers who had suffered through countless breakdowns. The psychological impact extended beyond individual crews to entire units. Modified panzer battalions developed pride in their mechanical reliability and operational effectiveness. They began viewing themselves as elite formations equipped with superior machinery. Standard units equipped with factory specification equipment became second-class formations limited by mechanical vulnerabilities. The modifications created capability gaps that translated into morale disparities. Colonel Ernst Böhm commanded the 15th Panzer Regiment, the first complete unit to implement Müller's modifications across all companies. His regiment's operational readiness had improved from 62% to 94% over 6 weeks. His tanks advanced faster, fought longer, and required less maintenance than any other armoured unit in 6th Army. But success created expectations that became problems. Higher command began assigning his regiment to the most difficult missions because they knew his tanks would function reliably. Objectives that would normally be assigned to full divisions were given to Böhm's single regiment. His unit became the crisis response formation for any situation requiring guaranteed mechanical performance. The reward for reliability was increased operational burden. Böhm's tank crews understood the pattern. Superior performance meant harder missions. Mechanical reliability meant greater operational risk. Success created expectations that exceeded reasonable limits. Crews who had gained confidence from reliable equipment began losing confidence from impossible assignments. The psychological benefits of mechanical improvements were offset by the tactical costs of excessive expectations. The situation reached crisis level on August 12th, when 6th Army headquarters assigned Böhm's regiment to capture and hold a strategic bridge 40 kilometers behind Soviet lines. The mission required penetrating enemy defenses, advancing through hostile territory, seizing the objective, and maintaining position until relieved standard doctrine would assign such a mission to an entire division with extensive support elements. Böhm's regiment was expected to accomplish the mission independently because their tanks were mechanically reliable. Higher command assumed that mechanical reliability translated directly into tactical capability. They ignored factors like ammunition capacity, fuel endurance, and crew fatigue that limited operational effectiveness regardless of mechanical performance. Reliable engines couldn't overcome tactical limitations. The mission succeeded, but at costs that revealed the fundamental problem. Böhm's regiment captured the bridge and held it for 36 hours, until relief arrived, but they expended 87% of their ammunition, consumed all reserve fuel supplies, and suffered crew exhaustion that reduced combat effectiveness by 40%. Mechanical reliability enabled tactical success, but couldn't eliminate tactical limitations. More significantly, the mission's success reinforced higher command's perception that modified units could accomplish impossible assignments. Böhm's regiment became the standard against which all other armoured units were measured. Their exceptional performance created expectations that spread throughout Army Group South. Every panzer regiment was expected to match the capabilities demonstrated by modified equipment. The pressure to implement modifications accelerated across all German armoured units. Regimental commanders who had resisted unauthorized changes began demanding immediate access to modification procedures. Division commanders who had questioned the legality of field modifications began authorizing implementation without waiting for official approval. The success stories from modified units overcame bureaucratic resistance. By August 15th, maintenance crews throughout Army Group South were implementing variations of Müller's original modifications. Some units achieved results comparable to the 15th Panzer Regiment. Others created mechanical disasters when inexperienced mechanics attempted complex procedures without adequate training. The modification process required expertise that couldn't be transferred quickly enough to meet demand. Sergeant Klaus Richter commanded a maintenance section in the 23rd Panzer Division, a unit that had received modification authorization but no qualified training personnel. His mechanics attempted to implement the procedures based on written descriptions and second-hand accounts. Their first attempt destroyed a Panzer IV's engine when improper fuel system modifications created combustion problems that melted cylinder heads. Their second attempt seized a transmission when inadequate understanding of gear ratios resulted in component stress that exceeded design limits. Their third attempt succeeded partially, creating an engine that ran reliably but produced only 70% of standard power output. Richter's section learned through trial and error, but error meant destroying irreplaceable equipment. The pattern repeated across dozens of maintenance sections throughout Army Group South. Mechanics with limited training, attempting complex modifications with inadequate supervision. Success rates varied dramatically based on individual skill levels, available tools, and quality of instruction materials. Some units achieved mechanical improvements comparable to properly trained sections. Others created maintenance disasters that reduced operational readiness below pre-modification levels. By late August, the modification program had created a three-tier system within German armoured forces. Elite units with properly trained mechanics operating highly reliable, modified equipment, standard units with factory specification equipment suffering normal mechanical failure rates, failed units with botched modifications operating equipment less reliable than original factory systems. The disparities created tactical problems that complicated operational planning. Elite units could sustain operations that standard units couldn't match. Failed units required additional support that reduced overall effectiveness. Army Group South was becoming a mixed capability force with unpredictable performance characteristics. Operational planning required accommodating units with dramatically different mechanical reliability levels. General Friedrich Paulus observed these developments with growing concern. His authorization of field modifications had produced measurable improvements in selected units, but it had also created systemic problems that threatened operational coherence. The Wehrmacht was built on standardization and predictable performance. Modified units performed better than standard, but their performance was inconsistent and difficult to predict. On August 20th, Paulus convened a conference of his division commanders to assess the modification program's impact on 6th Army operations. The discussion revealed fundamental tensions between individual unit effectiveness and overall operational coordination. Modified units performed exceptionally when properly implemented, but created planning difficulties when their capabilities exceeded standard assumptions. The conference produced no easy solutions. Paulus could halt the modification program and return to standard procedures, accepting lower mechanical reliability but restoring operational predictability. Or he could expand the program systematically, ensuring proper training and quality control while accepting temporary disruption. Both choices involve significant risks with uncertain outcomes. The decision was postponed by events beyond Paulus's control. On August 23rd, Soviet forces launched a major counteroffensive that threatened to encircle advanced German positions. The crisis required immediate tactical responses that had no time for administrative decisions about maintenance procedures. Modified and standard units fought side by side against Soviet attacks. their mechanical differences becoming secondary to survival. The Soviet counteroffensive struck with devastating precision. Marshal Vasily Chuikov had positioned 3 tank brigades and 2 rifle divisions in concealed positions northeast of the German salient. When the attack began at dawn, German forward observers counted 180 T-34 tanks advancing in coordinated waves. The modified panzers that had performed brilliantly during the advance now faced their ultimate test under defensive conditions. Major Heinrich Stolz commanded a mixed battalion of 18 tanks, 12 with Müller's modifications and 6 with factory-standard equipment. The approaching Soviet armour would reach his positions in 47 minutes. His modified tanks could manoeuvre continuously without mechanical failure. His standard tanks would require careful management to prevent breakdown during extended engagement. The tactical disparity that had complicated offensive operations now became critical for defensive survival. Stolz positioned his modified panzers in forward defensive positions where they could engage Soviet armour at maximum range. His standard tanks occupied secondary positions where mechanical reliability mattered less than concentrated firepower. The deployment violated doctrine that required uniform capability across defensive lines. But doctrine hadn't anticipated mechanical disparities within the same unit. The engagement began at 0734 hours when Soviet T-34s entered effective range at 1,200 meters. Stolz's modified panzers opened fire immediately, their reliable engines maintaining optimal power for turret traverse and gun elevation. Standard panzers held fire until targets close to 800 meters, conserving mechanical stress for critical moments. The staggered engagement created confusion in German fire control, but maximized each tank's capabilities. Soviet tactics hadn't anticipated the mechanical reliability that modified German tanks demonstrated. T-34 commanders expected panzers to suffer mechanical failures during extended combat, creating opportunities for flanking maneuvers. Instead, they encountered German tanks that maintained continuous operation throughout 4-hour engagements. Modified panzers fired 340 rounds per tank during the battle, triple the rate that Soviet intelligence estimated German armour could sustain. The battle's outcome revealed both strengths and weaknesses of the modification program. Modified tanks destroyed 43 Soviet vehicles while suffering only 2 mechanical failures. Standard tanks destroyed 19 Soviet vehicles but suffered 7 mechanical breakdowns that removed them from combat. The capability gap within Stolz's battalion was wider than the gap between German and Soviet equipment. But mechanical reliability couldn't overcome tactical limitations. Modified panzers that could fight continuously still faced ammunition constraints, crew fatigue, and fuel consumption that limited operational endurance. When Soviet reserves committed fresh T-34 brigades to the assault, German tanks with empty ammunition racks couldn't continue fighting regardless of mechanical condition. Reliability extended combat capability, but couldn't eliminate resource limitations. Captain Müller watched the engagement from his maintenance position 800 meters behind the defensive line. His modifications had transformed German armour reliability, but they had also revealed new vulnerabilities. Tanks that could operate continuously consumed resources continuously. Supply systems designed for equipment with regular mechanical downtime couldn't support machinery that never stopped working. The ammunition shortage became critical at 11:47 hours when modified panzers began reporting empty ready racks. These tanks had fired continuously for 4 hours, expending their basic load plus reserve supplies. Standard tanks had conserved ammunition due to mechanical limitations, firing only when targets presented optimal opportunities. Modified tanks had shot at everything within range, achieving higher kill ratios but exhausting supplies faster. Stolz faced an impossible choice: order his modified tanks to withdraw for resupply, abandoning defensive positions to Soviet advance, or order them to remain in position without ammunition, hoping their presence would deter Soviet assault. Either decision wasted the mechanical advantages that modifications provided. Reliable engines became useless when ammunition racks were empty. The tactical solution came from an unexpected source. Sergeant Wilhelm Baer commanded a supply convoy that had been rerouted to support Stolz's battalion. His trucks carried ammunition intended for 3 different units, but the fluid tactical situation had consolidated German forces into defensive positions that required flexible logistics. Baer made a field decision to deliver all ammunition to Stolz's position, regardless of original destination. The ammunition resupply reached German positions at 12:03 hours, 37 minutes after modified panzers had fired their last rounds. Soviet forces had advanced 400 meters during the ammunition gap, reaching positions that threatened German defensive integrity. The delay demonstrated how mechanical reliability created new dependencies that traditional logistics couldn't accommodate. Modified panzers resumed firing at 12:09 hours with full ammunition loads and mechanical systems that had operated flawlessly throughout the engagement. Their reliability advantage was restored, but the 37-minute gap had cost tactical position that required 2 hours of additional fighting to recover. Mechanical success had created logistical vulnerability that negated operational advantages. The pattern repeated across multiple engagements throughout late August and early September. Modified German tanks fought more effectively than standard equipment, but consumed resources at rates that strained supply systems. Their reliability enabled sustained combat operations that exceeded logistical planning assumptions. Success in mechanical engineering created problems in operational logistics. Lieutenant Colonel Franz Dietrich commanded supply operations for the 14th Panzer Corps, responsible for supporting 11 tank battalions with varying modification levels. His calculations were becoming increasingly complex as different units consumed fuel and ammunition at dramatically different rates. Standard formulas for resource planning became worthless when equipment reliability varied by 50% between units. Dietrich's solution was to establish resource allocation based on actual consumption rather than doctrinal estimates. Units with modified equipment received larger fuel and ammunition allocations to support their increased operational tempo. Units with standard equipment received allocations calculated on traditional failure rates. The system worked logistically, but created administrative complexity that strained headquarters staff. The administrative burden extended beyond supply calculations to maintenance planning, operational scheduling, and tactical deployment. Modified units required different support than standard units. Their capabilities enabled missions that standard doctrine couldn't accommodate. Their resource consumption demanded logistics that traditional systems couldn't provide. The Wehrmacht's bureaucratic structure wasn't designed for mixed capability forces. Major Rudolf Steiner served as operations officer for the 3rd Panzer Army, responsible for coordinating 12 divisions with varying equipment modifications. His daily briefings included mechanical readiness reports that showed operational percentages ranging from 47% to 96%, depending on modification implementation. Planning operations with such capability, disparities required constant recalculation of force ratios and mission assignments. Steiner's staff developed new operational categories to accommodate the mechanical variations, Category A units with properly implemented modifications and 90% plus readiness rates. Category B units with standard equipment and 70% average readiness, Category C units with failed modifications and below standard reliability. Each category required different mission assignments, support allocations, and tactical employment. The categorization system solved planning problems but created morale issues. Category A units viewed themselves as elite formations equipped with superior technology. Category C units felt penalised for attempting improvements that hadn't succeeded. Category B units resented being classified as standard when they maintained equipment according to official procedures. The mechanical improvements that enhanced capability created social divisions that weakened unit cohesion. Colonel Hans Richter commanded the 7th Panzer Regiment, a Category C unit, whose modification attempts had reduced mechanical reliability below factory standards. His mechanics had attempted Müller's procedures without adequate training, creating engines that consumed excessive fuel and transmissions that failed under normal stress. The regiment's operational readiness had dropped from 68% to 41% over 6 weeks. Richter's tanks required twice the maintenance support of standard equipment while providing reduced performance. His crews had lost confidence in their machinery, developing defensive tactics that minimized mechanical stress rather than maximizing combat effectiveness. The psychological impact of unreliable equipment was worse than the mechanical problems themselves. The solution required rebuilding 37 tanks with proper modification procedures implemented by qualified personnel. Müller and his training team arrived at Richter's position on September 8th to supervise the reconstruction program. The work required stripping failed modifications and rebuilding engines and transmissions using correct techniques and properly manufactured components. The reconstruction took 18 days and consumed resources equivalent to building new tanks. Müller's team worked 16-hour shifts, training Richter's mechanics while rebuilding their equipment. The process was expensive, time-consuming, and disruptive to operations, but it was the only way to restore Category C units to functional status. Results were dramatic but gradual. Richter's first properly rebuilt tank achieved 92% readiness over 14 days of testing. The second achieved 89%. By October 1st, 15 rebuilt tanks were operating at Category A standards, while 22 remained in various stages of reconstruction. The regiment was transitioning from Category C to Category A, but the process required sustained effort and significant resources. The reconstruction program revealed the true cost of implementing field modifications without proper training and quality control. Failed modifications were more expensive to correct than standard maintenance procedures. The resources required to rebuild botched modifications could have supported new tank production. Innovation without expertise created waste that exceeded any potential benefits. General Paulus reviewed these developments during his October 3rd staff conference. The modification program had produced remarkable successes in properly implemented cases, but it had also generated failures that consumed resources without providing benefits. The overall impact on 6th Army was positive but inconsistent. Some divisions operated at unprecedented effectiveness levels, while others struggled with self-inflicted mechanical problems. The strategic implications were becoming clear. German industry could support either widespread implementation of proven modifications or continued production of standard equipment, but not both simultaneously. Resources devoted to modification programs reduced factory output of new tanks. Training mechanics in modification procedures meant fewer mechanics available for standard maintenance. Success in one area required sacrifice in another. Paulus faced a command decision that would affect the entire Eastern Front campaign. Authorize systematic expansion of the modification program across all German armoured forces, accepting short-term disruption for long-term capability improvement, or restrict modifications to selected elite units while maintaining standard procedures for the majority of forces, accepting lower overall performance to preserve operational predictability. The decision was complicated by intelligence reports about Soviet armour production. Red Army factories were producing T-34 tanks at rates that exceeded German panzer production by 40%. Soviet numerical superiority was increasing monthly, while German forces relied on mechanical superiority to maintain tactical effectiveness. Modifications that improved German tank reliability became critical for offsetting Soviet numerical advantages. But modifications also created vulnerabilities that Soviet intelligence was beginning to exploit. Intercepted Soviet communications indicated awareness of German mechanical improvements and tactical adjustments designed to counter them. Red Army commanders were developing tactics specifically intended to overwhelm modified German tanks through sustained operations that exploited their increased resource consumption. The Soviet response was typically Russian in its brutal simplicity. If German tanks could operate continuously, Soviet forces would force continuous operations until German logistics collapsed. T-34 brigades began executing prolonged engagements designed to exhaust German ammunition supplies. Katyusha rocket batteries targeted German supply convoys. To disrupt fuel delivery, Soviet infantry infiltrated German rear areas to attack maintenance facilities where modifications were implemented. The campaign was becoming a contest between German mechanical innovation and Soviet logistical disruption. Modified German tanks performed superbly in individual engagements, but struggled when sustained operations exceeded supply capabilities. Soviet forces couldn't match German mechanical reliability, but they could exploit the resource dependencies that reliability created. On October 15th, the contest reached its climax when Soviet forces launched Operation Saturn, a coordinated offensive designed to exploit German logistical vulnerabilities. 3 Soviet armies attacked German positions simultaneously, forcing continuous defensive operations that would test modified tank capabilities under maximum stress. The engagement would determine whether mechanical improvements could overcome logistical limitations under combat conditions. The battle began at 04:45 hours, with the largest artillery barrage German forces had experienced on the Eastern Front. Soviet guns fired for 97 minutes, targeting German supply routes, maintenance facilities, and fuel depots. The bombardment was designed to disrupt logistics before armoured engagement began. When T-34 tanks advanced at 06:22 hours, they faced German panzers with full fuel tanks but uncertain supply lines. Modified German tanks fought brilliantly during the initial engagement, destroying Soviet armour at ratios that exceeded 3:1. Their mechanical reliability enabled sustained fire that Soviet commanders hadn't anticipated, but the engagement consumed ammunition and fuel at rates that tested German supply systems beyond their limits. By 1400 hours, advanced German positions were reporting critical shortages of both resources. The logistical crisis that German modifications had created was becoming a tactical disaster that Soviet planning had anticipated. Soviet logistics officers had studied German modification reports captured during earlier engagements. They understood that reliable German tanks consumed resources at predictable rates when operating continuously. Colonel Dmitry Volkov commanded the 3rd Guards Tank Army's supply operations. His calculations showed that German forces with 90% mechanical readiness would exhaust basic ammunition loads in 6 hours of sustained combat. Fuel consumption would reach critical levels after 8 hours. The mathematics were brutal but simple. Volkov's strategy was to force continuous engagement beyond German supply capabilities. Soviet armour would accept heavy losses during initial contact, but maintain pressure until German logistics collapsed. T-34 production rates could absorb tactical losses that German industry couldn't match. The Red Army would trade tanks for time until modified panzers became immobilized by empty fuel tanks and ammunition racks. The strategy worked exactly as Soviet planners anticipated. By 16:30 hours, German positions were reporting ammunition shortages across multiple sectors. Modified tanks that had fought flawlessly for 11 hours were reducing fire rates to conserve remaining rounds. Crews who had gained confidence from mechanical reliability were losing morale as resource limitations imposed tactical restrictions they couldn't overcome through superior engineering. WWII Major Wilhelm Krüger commanded 18 modified panzers in the 24th Panzer Division's defensive sector. His tanks had destroyed 47 Soviet vehicles since dawn, while suffering 0 mechanical failures, but they had also expended 83% of their ammunition and 71% of their fuel. Soviet T-34s continued advancing despite catastrophic losses because fresh brigades replaced destroyed units. Every 4 hours, Krüger's situation illustrated the fundamental problem with mechanical modifications. Reliable engines enabled sustained combat operations that exceeded logistical support capabilities. His tanks could fight indefinitely if supplied with fuel and ammunition. But supply convoys couldn't reach forward positions under continuous Soviet artillery. Fire mechanical reliability became irrelevant when ammunition racks were empty. The crisis deepened at 1847 hours, when Soviet forces began their third major assault of the day. Fresh T-34 brigades advanced through the wreckage of earlier attacks, while German defenders conserved their remaining ammunition for point-blank engagements. Modified panzers that had dominated long-range gunnery duels were forced into close combat, where mechanical advantages mattered less than crew skill and tactical positioning. Staff Sergeant Ernst Müller watched the battle from his maintenance position and understood the implications immediately. His modifications had created tanks that could fight continuously, but continuous fighting required continuous supply. German logistics weren't designed to support equipment that never broke down. Supply calculations assumed mechanical failures would create natural pauses in operations. When those pauses disappeared, supply systems couldn't adapt. The irony was crushing for mechanics who had worked months to eliminate mechanical unreliability. Their success had created logistical unreliability that was worse than the original problem. Broken tanks could be repaired in field workshops. Empty fuel tanks required supply convoys that couldn't reach forward positions under enemy fire. Mechanical problems had solutions. Logistical problems required miracles. At 21:34 hours, Soviet artillery began targeting German maintenance areas specifically. Katyusha rockets struck repair facilities where Müller's modifications were being implemented. The attacks weren't random. Soviet intelligence had identified modification centers as critical vulnerabilities in German operational capability. Destroying the facilities that performed modifications would force German forces back to standard equipment with higher failure rates. The bombardment destroyed 3 complete maintenance facilities and damaged 7 others. Equipment for performing modifications was scattered across kilometer-wide impact zones. Trained mechanics who understood modification procedures were killed or wounded. The knowledge base that supported the entire program was being systematically eliminated by Soviet targeting. Lieutenant Colonel Hans Weber observed the destruction from division headquarters and realized the broader implications. The modification program had created dependencies that Soviet forces were exploiting methodically. Modified units required specialized maintenance support that standard units didn't need. When that support was destroyed, modified equipment became more vulnerable than standard machinery. Weber's division included 2 regiments with modified equipment and 1 with standard factory specifications. The modified regiments had operated at 94% readiness for 6 weeks. After the Soviet bombardment, their readiness began declining as mechanical problems accumulated without qualified repair capabilities. The standard regiment maintained steady 68% readiness using conventional maintenance procedures. By October 18th, the tactical situation had reversed completely. Units with standard equipment were maintaining operational capability, while modified units suffered increasing mechanical failures. The knowledge and facilities required to support modifications were being destroyed faster than they could be replaced. German forces were losing their mechanical advantage just when they needed it. Most Colonel Ernst Richter commanded the 12th Panzer Regiment. one of the first units to implement Müller's modifications successfully. His tanks had achieved 96% operational readiness through September, earning recognition as the most reliable armoured unit in Army Group South. But Soviet targeting of maintenance facilities had eliminated his specialised repair capabilities. His modified tanks were beginning to fail at rates that exceeded standard equipment. The first failures appeared on October 19th, when modified fuel systems began malfunctioning due to contamination from low-quality replacement fuel. German logistics were shipping whatever fuel was available rather than the refined products that modified engines required. Standard engines could operate on crude fuel mixtures. Modified engines, optimized for reliability under ideal conditions, failed when forced to run on substandard supplies. Transmission problems followed on October 21st, when simplified gear systems began breaking under sustained combat stress. The modifications had traded complexity for reliability, but they had also reduced safety margins that protected components. Under extreme conditions, standard transmissions failed predictably. Modified transmissions failed catastrophically when their reduced safety margins were exceeded. Cooling system failures occurred on October 23rd, when modified radiators became clogged with debris from destroyed Soviet vehicles. The simplified cooling systems worked efficiently under normal conditions, but couldn't handle the contamination levels created by intensive combat. Standard cooling systems had redundant capacity that accommodated debris loading. Modified systems had eliminated that redundancy to improve efficiency. By October 25th, Richter's regiment had declined from 96% to 51% operational readiness. The mechanical advantages that had made his unit elite were disappearing as modified systems failed without specialized repair support. His tanks were becoming less reliable than standard equipment, but they couldn't be converted back to factory specifications without complete rebuilds. The pattern repeated across all units, equipped with modified machinery. Systems optimized for reliability under ideal conditions became vulnerable when those conditions changed. Modifications that had solved problems under controlled circumstances created new problems under combat stress. German armour was losing its mechanical superiority just as Soviet pressure reached maximum intensity. General Friedrich Paulus received reports on the deteriorating mechanical situation during his October 26th morning briefing. Units that had achieved exceptional reliability through modifications were suffering failure rates that exceeded pre-modification levels. The specialized maintenance capability that supported the program was being systematically destroyed by Soviet targeting. Sixth Army was losing its mechanical advantage when strategic success depended on equipment superiority. Paulus faced the consequences of his decision to authorize field modifications without adequate support infrastructure. The modifications worked brilliantly when properly supported but became liabilities when that support was eliminated. He had created dependencies that Soviet intelligence had identified and exploited. His tactical success had become strategic vulnerability. The solution required choosing between impossible alternatives. Commit remaining resources to rebuilding modification support capabilities, accepting reduced combat strength to restore mechanical advantage, or abandon the modification program completely, returning to standard equipment while accepting lower performance levels. Both choices involved significant risks with uncertain outcomes. The decision was forced by events on October 28th, when Soviet forces launched their final offensive toward German positions. 3 complete armies attacked simultaneously, supported by artillery concentrations that made supply operations impossible. German forces would fight with whatever equipment they possessed at the moment of attack. No resupply, no reinforcement, no repair support would reach forward positions. Modified German tanks fought with mechanical systems that were beginning to fail, while Soviet T-34s advanced with equipment that was crude but functional. The contest between German innovation and Soviet mass production reached its final phase. Sophisticated German engineering faced overwhelming Soviet numbers under conditions that favoured quantity over quality. The engagement lasted 47 hours before German resistance collapsed. Modified panzers that had dominated earlier battles were immobilised by mechanical failures, empty fuel tanks, and exhausted ammunition. Soviet forces captured intact German tanks that couldn't move due to transmission seizures, fuel starvation, and cooling system breakdowns. The modifications that had promised to solve German mechanical problems had created new vulnerabilities that proved decisive. Staff Sergeant Ernst Müller was captured on October 30th while attempting to repair a broken transmission in his workshop behind German lines. Soviet engineers immediately recognized the significance of the equipment and personnel they had captured. The mechanic who had created modifications that enhanced German tank reliability was now a prisoner whose knowledge would help Soviet forces understand German innovations. Soviet interrogation revealed the complete scope of the German modification program. Müller described the technical procedures, training methods, and implementation strategies that had transformed German armour capability. His information helped Soviet intelligence understand why German tank performance had improved dramatically during the summer campaign, and why it had declined during the October fighting. The intelligence was invaluable for Soviet tactical planning, but also revealed the broader implications of the modification program. German forces had achieved temporary mechanical superiority through field innovation, but they had also created vulnerabilities that could be exploited systematically. The program's success had generated dependencies that became decisive weaknesses when properly targeted. Marshal Georgy Zhukov reviewed the interrogation reports and understood immediately why German resistance had collapsed so completely. The Wehrmacht had modified their equipment to achieve superior performance, but they had also eliminated the redundancy and robustness that sustained operations under adverse conditions. German tanks worked perfectly under ideal circumstances, but failed catastrophically when those circumstances changed. The lesson was applicable beyond tank modifications to the entire German war effort. Sophisticated engineering solutions optimized for specific conditions became liabilities when conditions changed unexpectedly. Simple, robust designs with built-in redundancy performed better under the chaos and unpredictability of actual combat. The Red Army's preference for crude but reliable equipment was vindicated by German experience with complex modifications. Soviet forces continued their advance toward German rear positions, capturing maintenance facilities, supply depots, and training centers that supported the modification program. Documents recovered from these facilities revealed the complete technical specifications, training procedures, and implementation strategies that German forces had developed. The intelligence provided insights into German engineering capabilities and tactical limitations. The captured information also revealed how quickly field innovations could spread through military organizations when they provided clear advantages. The modification program had grown from one mechanic's experiment to army-wide implementation in less than 4 months. The speed of adoption demonstrated both the effectiveness of the modifications and the desperation of German forces facing mechanical reliability problems. But the rapid expansion had also created the vulnerabilities that Soviet forces exploited successfully. Modifications implemented without adequate training and quality control created equipment that was less reliable than standard machinery units that attempted modifications beyond their technical capabilities, reduced their operational effectiveness below acceptable levels. Innovation without expertise generated waste rather than improvement. The German modification program became a case study in both the potential and the risks of field innovation. Properly implemented modifications could transform equipment capability dramatically, but implementation required expertise, resources, and infrastructure that weren't always available under combat conditions. Success in controlled circumstances didn't guarantee success under operational stress. By November 15th, Soviet forces had captured or destroyed most of the facilities, personnel, and equipment associated with the German modification program. The knowledge base that had enabled German mechanical superiority was scattered across prisoner-of-war camps and destroyed maintenance facilities. The program that had promised to solve German reliability problems had become another casualty of the Eastern Front campaign. The final irony was that some German units continued operating modified equipment successfully throughout the remainder of the war. Small formations with properly trained mechanics and adequate supply support maintained the mechanical advantages that modifications provided, but these successes were isolated exceptions that proved the rule rather than disproving it. Innovation required support systems that weren't sustainable under combat conditions. Lieutenant Hans Weber served with one of these successful units, a company-sized formation that maintained 90% operational readiness through proper modification procedures and disciplined resource management. His tanks fought effectively until the final collapse of German resistance in May 1945. The modifications that had been developed by studying Ford trucks in a captured Soviet supply depot continued providing advantages until the war's end. But Weber's success was exceptional rather than typical. Most German units equipped with modified machinery suffered mechanical failures that reduced their effectiveness below standard levels. The program that had begun with such promise ended as another example of how complex solutions could create more problems than they solved. The Wehrmacht learned too late that sophisticated engineering was no substitute for adequate logistics and proper training. The legacy of Müller's modification program extended beyond immediate tactical results to influence post-war military development. Both American and Soviet engineers studied captured German technical documents to understand how field modifications could enhance equipment performance. The lessons learned influenced tank design philosophy for decades after the war ended. American tank development incorporated simplicity principles that Müller had borrowed from Ford truck engineering. Post-war American tanks emphasized reliability and maintainability over performance optimization. The M48 and M60 tank designs reflected lessons learned from German modification experiences about the importance of field serviceability and logistical sustainability. Soviet tank development moved in the opposite direction, emphasizing mass production of simple, robust designs that could operate under adverse conditions without modification. The T-54 and T-55 series incorporated crude but reliable systems that functioned effectively regardless of maintenance quality or supply availability. Soviet engineers concluded that standardization and simplicity were more valuable than innovation and optimization. The German modification program demonstrated both the potential and the limitations of field innovation under combat conditions. Properly implemented, modifications could transform equipment capability dramatically, but implementation required resources and expertise that weren't always available when needed most. The program's ultimate failure illustrated why military organizations emphasize standardization and proven procedures over individual innovation and experimental solutions. Hans Müller died in Soviet captivity on January 12, 1943. Pneumonia in a prisoner-of-war camp near Stalingrad. He was 25 years old, the mechanic who had studied Ford trucks for 2 hours and changed how an entire army maintained its tanks never learned that his modifications had spread to thousands of German vehicles, never knew that his innovations had enabled tactical successes that prolonged the Eastern Front campaign by months. Never understood that his simple solutions had created complex problems that contributed to Germany's ultimate defeat. The irony would have been lost on him anyway. Müller was a mechanic, not a strategist. He saw broken tanks and fixed them, saw unreliable systems and simplified them. saw German engineering failing under combat stress, and borrowed American solutions that worked. His modifications succeeded brilliantly at the tactical level, while failing catastrophically at the strategic level. Individual innovation couldn't overcome systemic limitations. The Wehrmacht captured millions of tons of American Lend-Lease equipment during the Eastern Front campaign: trucks, tanks, aircraft, weapons systems designed for reliability rather than sophistication. German engineers dismissed most of it as crude compared to their precision machinery, but one mechanic looked deeper, saw the philosophy behind the engineering, understood that simple systems working consistently beat complex systems working perfectly until they broke. Müller's legacy lived in every post-war tank that prioritized field maintenance over factory precision, every engine designed to run on multiple fuel types rather than optimized mixtures, every transmission built for abuse rather than efficiency. The lessons he learned from Ford trucks influenced military vehicle design for decades after his death. Innovation, born from desperation, became doctrine implemented through deliberation.